Good day, ladies and gentlemen, and you're very welcome to this week's technical session of the CNPS. Right. Just one or two announcements. The main thing I wanted to inform you about is that for the last number of months, actually since the beginning of this year, we've been mentioning the funding mechanism that was instigated in January, and we've been playing a brief video given by the president of the organization, David Hilster. Now, I've just been informed actually that we've now closed the funding mechanism. I think it's basically reached what it had hoped to. Because there was a shortfall between, the income from membership dues and what we needed for the running of the organization. So that's closed now. So you might be glad that I'm not going to play the video again, just asking you for contributions, because it's impossible to contribute anymore. But thank you very, very much for all your contributions. And I understand it's been very, very successful in helping to bridge this shortfall. So therefore, we'll have a little more time to delve straight into the presentation. And I'm delighted to say that you probably see it's nice and bright here in Hibernia, the land of perpetual winter. We now have beautiful sunshine. It's well above 20 degrees. It's quite exceptional. We have what we would call a heat wave, a late spring heat wave. So I don't feel envious of you in the southern part of the United States, say, who are getting lovely sunny weather, and other parts of Europe. Right. Well, let's get into the substance of today's presentation. And I'm delighted to be able to welcome back Vladimir Netchitailo, who is going to present part 4 of this 8-part series on his world universe model. So today, these are sessions which we hold every 2 weeks, because I moderate them every 2 weeks, and Roger Anderton does the other weeks. But it's actually a blessing in disguise that there's a lot of very intense material in Vladimir's model, and he's applying it to different aspects of cosmology and fundamental physics and so on. So I feel, anyway, if I may say so, that I feel it's actually advantageous that we have a week to think about what he's been saying. And in my case, I look back on the video quickly and look back at some parts, and then maybe we have another week to think about it before he comes to his next part. So we'll be entering into, maybe after today, we'll be halfway through his presentations. Now, the last time, 2 weeks ago, he dealt with the very fundamental part of angular momentum and some discrepancies there. Today, he's applying it to the Milky Way galaxy, our own galaxy. And basically, the description, to remind you, is that he'll be providing experimental observations related to the Milky Way galaxy and our neighboring galaxy, which is the Andromeda galaxy, and explain them in frames of WUM, the world universe model. I think world is used in the sense of universal, in that sense, not restricted to our globe. He'll concentrate on observations of the Milky Way Centre by NASA and the Event Horizon Telescope collaboration, and analyze them, the observations, in frames of WUM. Discuss experimental results for Fermi Bubbles and propose explanation of them by WUM. So we're moving on from our previous fairly fundamental talk last week, and now we're applying the WM to the observations which we have on the cosmological scale. Now, I understand Vladimir is very, if I may say so, as moderator, is a very clear speaker, because he has the system which is projected up there, and he's basically reading it from it, and we can actually read it ourselves. The format is normally, and it's been working very successfully, that we give the speaker time, maybe something like an hour or so. It doesn't matter if he goes over that for his presentation. Now, there will be time after the presentation, perhaps up to an hour as well, for discussion and in particular questions and answers. So if any specific questions come up, you might just preface them that this is a specific question for Vladimir, because 80%, perhaps more and more, of the exchanges are really conversations between the participants, and that's all very welcome. We've no problem with that. In fact, we encourage that. But it's possible that you'll have a question for Vladimir which may be lost in the general melee, and so if you just say this is a question, if there's anything very, very urgent, you could maybe put the question, this is urgent, I really think I didn't understand the word he said, or with a pronunciation or something. If you really have something like that, we would be prepared to take it during the session. But all else being equal, we prefer to wait until the end of the session. And then, of course, there will be a more detailed discussion, because we have a number of people in the green room. We have a maximum of 10 persons that are permitted, so we would ask you to clear that beforehand. But we have a number of regulars coming in, and I think we have about 5 so far, so we can fit more people. And I just remember I have this problem. I better do it. I'm just going to paste the exact link to the green room, because some people find that their computers remember the previous session, and if they go into the generic link which we gave in the announcement, they get last fortnight session, which is no good. So sorry, I haven't pasted the thing in. There it is. I just said green room, but now I have the I thought I had it in. Let me see now. Green room. Let me try again. Sorry for this, but it is important to allow anybody to be able to get in. Okay, just paste that now. Very well. So there's the link. Okay, so Vladimir is here. I've had some preliminary conversation with him. You're up there, Vladimir, and I think you and I just have to remember quickly what we did previously. So you shared your screen, I think, directly, and then I put it up from the link here. So if you want to do that before I get rid of myself.
I can put it now.
Yeah, if you put it there, because when you put it, you'll find it hasn't come up immediately. I then had to bring it up, and I'll do that as soon as I see it.
Okay.
Let me see. I've forgotten whether it was your screen or the slides that you projected.
It will be screen.
Okay, I think that's the best one, actually.
Yes.
Now it's okay. It's there. I'm going to put it up now. It's up there. Well, it should be. And I'm going to hand over to you, and then I'm going to maximize the screen so that your image isn't there, but your voice is. And then when you're finished, we'll all come back. Is that all right? And if you need me, I'll be silent because I'm going to disappear. But if you need me, just shout that.
Okay.
Okay. So we look forward to your Part 4 Milky Way Galaxy.
Can I start?
Yeah, please start. Please start. I didn't say that. Please start now. The floor is completely yours, Vladimir.
Thank you so much. Hello, everyone. Thank you so much for coming. Let's start. Considering the questions you asked me the last session, I composed the following new section: dark matter non-acceptance. Why? The basic feeling of many physicists is that dark matter doesn't exist because they believe that the dark matter construct was erroneously created due to a false analysis of the expected rotational velocity of stars in the outer range of spiral galaxies, and also presumably due to lack of knowledge about other evidence for dark matter. It is worth noting that in frames of world universe model, there is no need in dark matter to explain galaxy rotation curves. Nick Percival, who knows the opinion of members of CNBS about dark matter, suggested me to put this sentence at the beginning of my second session. I've done it. I'm absolutely agree with him, and I'm grateful to him very much for this suggestion. The main results of the second presentation, multi-component dark matter, are critical energy density of the world, which provides its flatness, can be found by the Hubble's law only. There is no need in general relativity. Medium consists of stable elementary particles, protons, electrons, photons, neutrinos, and dark matter particles. The relative energy density of ordinary particles, about 4.8% in the medium, which was experimentally measured by fast radio bursts, 2.4% in macro objects, and the rest, 92.8%, is the relative energy density of dark matter particles. What else it could be? In whom there is no dark energy, which is an unknown form of energy that affects the universe on the largest scales. Its primary effect is to drive an erroneously created accelerating expansion of the universe, contributing 68% of the total energy. The nature of dark energy is more hypothetical than that of a dark matter, and many things about it remain in the realm of speculation. In my previous presentation, Angular Momentum, De Hilster wrote the following comment. The word dark is a canary in the coal mine that screams something fundamentally wrong with modern cosmology. It doesn't exist. It is artifact of failed theory. At the same time, Nick Percival said that dark matter womb is really empirically driven model rather than someone doing mathematical manipulation. The host of the session, Ian Cohen, asked the perfect question that demonstrated his deep understanding of the multi-component dark matter. Do you conceive of dark matter as being analogous in atomic constitution to ordinary matter? There are principally different opinions about dark matter. Why? In my opinion, there are two different issues with dark matter objects and dark matter particles. Usually, dark matter objects are accepted because the existence of them is experimentally proved. 240 years ago, John Mitchell predicted binary systems in which a dark star and a normal star orbit around their center of mass, and they were identified by astronomers in 1971, 180 years later. Binary galaxy systems, including dark galaxies, were discovered by Giovanelli and Haynes in 1989 and by Minchin et al. In 2000. In 1933, Zwicky investigated the velocity dispersion of Coma supercluster and found a surprisingly high mass-to-light ratio, about 500. He concluded, if this would be confirmed, we would get the surprising result that dark matter is present in much greater amount than luminous matter. Masses of superclasses can be estimated by gravitational lensing also. The main issue is with dark matter particles, for which there are no direct observations. They have no electrical charge and cannot be investigated by mass spectrometry. I would like to stress that there are many particles without electrical charge. Neutron, neutrinos, gluon, Higgs boson, etc. Nevertheless, we accept them without direct observations. Why do we have so much prejudice against dark matter particles? Indirect effects in cosmic rays and gamma ray background from the annihilation of cold dark matter in the form of heavy, stable, neutral leptons in galaxies were considered in pioneer article by Nobel Prize laureates in physics Lee and Weinberg in 1977. Bohm follows this idea and introduces a multi-component system of self-annihilating dark matter particles that behave like Majorana fermions, which are their own antiparticles. In 1952, Nobel laureate in physics Nambu proposed an empirical mass spectrum of elementary particles with a mass unit m0 over 2 close to 1/4 of the mass of pion. He noticed that meson masses are even multiplies of a mass unit. Baryon and also unstable lepton masses are odd multiplies, and mass difference among similar particles are quantized by m0 70 megaelectron volts. In whom I introduced a basic energy unit E0 that equals to 70 megaelectron volt, where R is the Planck constant, C is the electrodynamic constant, and A is a basic size unit. I emphasize that the rest energy of electron equals to alpha multiplied E0, and the Rydberg unit of energy equals to half alpha cube E0. R is the Rydberg constant. It is the main goal of WOM to develop a model based on two-dimensionless parameters only. Dimensionless Rydberg constant alpha, that named now fine structure constant. Dimensionless time-varying quantity Q, that is a measure of the size R and HRA tau for the world Q equals R over A tau over T0, where T0 is a basic time unit, which in a present epoch, I mean Q, equals to the value 0.76 multiplied 10 to the power 4, and is in fact the Dirac large number. Considering the main goal of WOM, the rest energies of dark matter particles should be proportional to constant alpha only. WOM postulates that rest energies of dark matter fermions and bosons are proportional to the basic energy unit E0 multiplied by different exponents of alpha and can be expressed with the following formula in the created model of dark matter particles. This is the formulas. In our view, this created table of dark matter particles covering 18 orders of magnitude of rest energies is the analogous in atomic constitution to ordinary matter, as Ian Cowan said in the previous presentation. The reason for this multi-component dark matter system is to explain the diversity of very high energy gamma ray sources in the world. In presentation 2, we discuss experimental conformations of the proposed dark matter particles in very high energy gamma spectrum. The diversity of dark matter cores of macro objects of the world, extrasolar systems, DMF1 and DMF2, galaxies, DMF3, superclusters, DMF4, which are fermion compact objects, and dark matter reactors in WOM. In presentation 3, we discuss macrostructures of the world with these dark matter cores. DMF4 are responsible for unidentified infrared emission bands. Main infrared features occur around peaks at 3.3, 6.2, 7.7, 8.6, 11.2, and 12.7 micrometers, which are fingerprints of all galaxies. Diracs, which are magnetic dipoles of Dirac monopoles, are introduced to explain the Dirac's quantization condition. All electric charge in the universe must be quantized. Allops, which are dipoles of prions with electrical charge E over 3, are the building blocks for quarks. Xions are responsible for lethargic mechanism of gravitation at broadband 21 centimeter emission. Introduction. The discovery of supermassive compact objects at the center of our galaxy, Nobel Prize in Physics 220, made by Genzel and Guess, is a confirmation of one of the most important predictions of WOM in 2013. Macro objects of the world have course made up of the discussed dark matter particles. Other particles, including dark matter and baryonic matter, form shells surrounding the cores. I would like to stress that Genzel and Guess named the object supermassive compact object, but not supermassive black hole, as it was only accepted explanation. There are no black holes in WOM. Recently, a population of large, very low surface brightness spheroidal galaxies was identified in the Coma cluster. One document in 2019 presents the stellar kinematics of Dragonfly 44, one of the largest Coma ultra-diffuse galaxies, whose mass about equals that of the Milky Way. However, the galaxy emits only 1% of the light emitted by Milky Way. Astronomers reported that this galaxy might be made almost entirely of dark matter. The existence of nearly dark objects with this mass is unexpected, as galaxy formation is thought to be maximally efficient in this regime. Lian and Slatier in 2019, in the article Revival of the Dark Matter Hypothesis for the Galactic Center Gamma Ray Access, examined the impact of unmodeled source populations on identifying the true origin of the galactic center gigaelectron volt access. The authors discovered striking behavior consistent with mismodeling effect of the real Fermi data, finding that large artificial injected dark matter signals are completely misattributed to point sources. Consequently, they conclude that dark matter may provide a dominant contribution to the galactic center gigaelectron volt access after all. On May 12, 2022, astronomers using the Event Horizon Telescope released the first image of the accretion disk around Sagittarius, produced using a worldwide network of radio observatories made on April 2017. These observations were analyzed by the international research team that now numbers over 300 people, which claimed that Sagittarius is a supermassive black hole. Below, we analyze these results in frames of WOM. Based on the totality of all accumulated results for the center of Milky Way, I conclude that Sagittarius is the dark matter core of our galaxy. WOM solves a number of physical problems in contemporary cosmology and astrophysics through dark matter particles and their interactions, angular momentum problem in birth and subsequent evolution of galaxies and extrasolar systems. How do they obtain it? We discussed this problem in the previous presentation 3. And Fermi bubbles, which are two large structures in gamma rays above and below galactic center. What is the mechanism of their radiation? We will discuss it below. Multi-universe model, macrostructures. Laniakea supercluster is a galaxy supercluster that is home to Milky Way and about 100,000 other nearby galaxies, see figure 1 and 2. It is known as one of the largest superclusters with estimated by Bliss binding mass 10 to the power 17 solar mass. Distance to the center of Laniakea supercluster is about 250 million light years. We emphasize that About 100,000 nearby galaxies are moving around center of Laniakea supercluster. They belong to Laniakea supercluster. All these galaxies did not start their movement from initial singularity. Neighboring superclusters have the same structure. It means that the world is in fact a patchwork quilt of main superclusters. Please, one more time, take a look at this real picture of our world. Macro-object jet model, in whom macrostructures of the world, superclusters, galaxies, extrasolar systems, have nuclei made up of dark matter fermions, which are surrounded by shells composed of dark matter and baryonic matter. The shells envelop one another like a Russian doll. The lighter a particle, the greater the radius and the mass of its shell. Innermost shells are the smallest and are made up of heaviest particles. Outer shells are larger and consist of lighter particles. A proposed weak interaction of dark matter particles provides integrity of all shells. We discussed this model in presentation 2. Table 2 describes parameters of macro objects cores, which are 3D fluid balls with a very high viscosity and function as a solid-state object, calculated based on the developed theory of fermion compact objects. The calculated parameters of the shells show that nuclei made up of DMF1 and DMF2 compose cores of dark stars and in galaxies and normal stars in extrasolar systems. Shells of DMF3 and electron-positron plasma around nuclei made up of DMF1 or DMF2 make up cores of galaxies. Nuclei made of DMF1 and DMF2 surrounded by shells of DMF3 and DMF4 compose cores of superclusters. Formation of macrostructure. In frames of womb, Laniakea supercluster emerged 13.77 billion years ago due to a random explosive volcanic rotational fission of the supercluster of a spinning surface speed at equator exceeding escape velocity, dark matter core, and self-annihilation of dark matter particles. Dark matter core of Laniakea supercluster was created during dark epoch, spanning from the beginning of the world, 14.22 billion years ago, for 0.45 billion years, when only dark matter macro objects existed. Dark matter core of Milky Way was born 13.77 billion years ago as the result of rotational fission of Virgo supercluster dark matter core. Dark matter cores of extrasolar systems, planets, and moons were born as a result of the repeating rotational fissions of Milky Way dark matter core in different times, 4.57 billion years ago for the solar system. Macrostructures of the world form from the top, superclusters, down to galaxies, extrasolar systems, planets, and moons. In our view, random explosive volcanic rotational fission of dark matter core of prime objects looks like a firework of dark matter cores of satellite objects at the same time, so that the direction of the sum of satellites' angular momentum coincides with the angular momentum of the prime object. Dark matter cores of prime objects detonate at critical points of their stability, which principally depend on the accumulated rotational angular momentum. We discussed it in presentation 3. Milky Way. Milky Way is a barred spiral galaxy, which is a part of the local group of galaxies that form part of the Virgo supercluster, which is itself a component of Laniakea supercluster. The age of Milky Way and the oldest star, named Methuselah, is similar to the age of the world. the galactic center as an intense radio source known as Sagittarius. In 2008, Guess et al. Found the enclosed mass of it 4.1 million solar mass. I emphasize that now with GWST, we are looking for the earliest and most distant galaxies, and at the same time, we live in one of the earliest galaxies, Milky Way. According to standard cosmology, massive mature disk galaxies with mass up to 10 to the power 11 solar mass cannot form for the amount of time 100, 400 million years, because it takes billion years to form them. So they should not be there at all. The experimental observations of galaxies in the fold show that most of them are disk galaxies. Milky Way is the second largest spiral galaxy in the local group after Andromeda galaxy, with its estimated visible stellar disk diameter 185 kilolight years, thickness of seen stellar disk about 2 kilolight years, and mass 1.6, 3.2, 10 to the power 42 kilograms. The disk bubble contains interstellar medium and 100, 400 billion extrasolar systems. With Nikola Tesla's principle at heart, there is no energy in matter other than that received from the environment. We calculate mass of Milky Way according to this simple equation. From this equation, we calculate diameter of Milky Way 170 to 240 kilolight years. The calculated value of the visible stellar disk diameter is in a good agreement with its estimated value obtained by astronomers. Considering the stellar disk diameter 185 kilolight years, we can calculate mass of Milky Way 1.92 10 to the power 42 kilograms. Average concentration of dark matter particles DMF3 in interstellar medium about 304 10 to the power 11 per cubic meter, which is significantly larger than the critical concentration that defines weak interaction, 5.3 10 to the power 10 per cubic meter. It means that weak interaction between dark matter particles DMF3 provides integrity of Milky Way disk bubble. Andromeda galaxy is a barred spiral galaxy about 2.5 million light years from the Earth, and the nearest large galaxy to Milky Way with about trillion stars. It has an estimated visible stellar disk diameter about 220 kilolight years and mass 3 10 to the power 42 kilograms. Parameters of Andromeda galaxies are close enough to the parameters of Milky Way. It seems reasonable that the calculations of the galaxy parameters made above for Milky Way are valid for Andromeda galaxy too. Considering the fact that the calculated concentration of DMF3 is significantly larger than the critical concentration, we can suppose that our conclusions for Milky Way are fair for all galaxies involved. In whom galaxies emerged due to the explosive volcanic rotational fission of overspinning dark matter supercluster cores composed of dark matter particles DMF1, DMF2, DMF3, and DMF4. As a result of this mechanism, galaxy bubbles created which have looked like chicken eggs at that time. Yolk, spinning liquid dark matter core of galaxy with high viscosity composed of dark matter particles DMF1, DMF2, and DMF3. Yolk contains 1/3 of the total galaxy matter. Albumin, liquid interstellar medium with low viscosity made of DMF3 with dissolved other dark matter particles. Albumin adds up to 2/3 of the total galaxy matter. membrane boundary between interstellar medium and intergalactic medium with surface energy density sigma 0. Extrasolar system emerged due to the explosive volcanic rotational fission of a spinning dark matter galaxy core and anti-interstellar medium. As a result, galaxy bubble expands in the plane of the spinning galaxy's dark matter core and becomes a disk bubble. Center of Milky Way. Sagittarius is a supermassive black object at the galactic center of Milky Way, which was discovered in 1954 by Krauss, Coe, and Matt with radio telescope at 250 megahertz. It is a bright and very compact astronomical radio source. In 1982, Brown understood that the strongest radio emission from the center of Milky Way appeared to be due to a compact, non-thermal radio object. The Sagittarius cluster is the cluster of stars in close orbit around Sagittarius. One of the most studied stars is S2. Take a look at the figure 3. Star S14 is the record holder of closest approach to Sagittarius at about 1.88 10 to the power 12 meters, almost as close as Saturn gets to the Sun. Its orbital period is 12 years, but an extreme eccentricity of 0.985 gives it the close approach and high velocity of about 8% of the speed of light. In 2005, Eisenhower et al. Reported the results with 75 milliaxis resolution of near-infrared imaging spectroscopy within the central 30 light days of the galactic center. Look at one more time at this figure. This is their results. On January 5, 2015, NASA reported observing from Sagittarius a record breaker X-ray flare 400 times brighter than usual. According to astronomers, the unusual event may have been caused by the breaking apart of an asteroid falling into supermassive black hole. Can you believe it? In 2018, von Fellenberg et al. Reported the first detection of the galactic center in the far infrared. Their measurements were obtained at 100 and 160 micrometers. In 2019, the observations of several stars orbiting Sagittarius have been used to determine the mass and upper limits on the radius of the object. Based on mass and increasingly precise radius limits, astronomers have found that the enclosed mass of Sagittarius is 4.154 million solar mass, compared with 4.1 million solar mass obtained by GESS in 2008. A calculated Schwarzschild radius of its mass, 1.227 10 to the power 10 meters, is about 2 orders of magnitude smaller than the minimum distance of star S14 from Sagittarius, 1.88 10 to the power 12 meters. On 2021, NASA published new images of the galactic center based on surveys from Chandra X-ray Observatory. Astronomers present a catalog of the detected X-ray sources in the range 0.37 kiloelectron volts. NASA has released a stunning new picture of our galaxy's violent, super-energized downtown. The image, a composite of 370 observations made over the past 2 decades, depicts Billions of stars in the center of Milky Way. The author of these investigations, Wang, said, what we see in the picture is a violent or energetic ecosystem in our galaxy's downtown. Warm explanation. The calculated value of the radius of the electron-positron shell, 2.9 10 to the power 10 meters, is in excellent agreement with the experimentally measured value of the radius source, 3 10 to the power 10 meters by Liu et al. The calculated value of the mass of electron-positron shell, 6.6 10 to the power 36 kilogram, is in a good agreement with the experimentally measured value of the supermassive compact object, 8.5 10 to the power 36 kilogram, by Guest et al. In 2008. The additional mass of DMF3 shell of 1.9 10 to the power 36 kilogram is much smaller than the maximum mass of it, 1.2 10 to the power 41 kilogram. X-ray flare 400 times brighter than usual, observed by Chu et al. In 2015, can be explained by the detonation of DMF3 particles and their self-annihilation. The excess of gamma-ray emission with energy about 10 gigaelectron-volt reported by Hooper in 2011 from the galactic center can be explained by DMF2 particle self-annihilation. The age of the Methuselah, found by Bond in 2013, can be explained by generation of this star by overspinning dark matter core of Milky Way 13.77 billion years ago. In frames of the rotational fission model, it is easy to explain hyper-runaway stars unbound from Milky Way with speeds of up to 700 kilometers per second. Marchetti et al. In 2018 observed it. They were launched by overspinning dark matter core of Large Magellanic Cloud with a speed higher than the escape velocity. Koposov et al. In 2019 present the discovery of the fastest main sequence hypervelocity star S5 with mass of about 2.3 solar mass that is located at a distance of about 9 kiloparsec from the Sun. When integrated backwards in time, the orbit of the star points unambiguously to the galactic center, implying that S5 was kicked away from Sagittarius with a velocity of 1800 kilometers per second and traveled for 4.8 million years to its current location. This discovery can be explained by gravitational burst of the overspinning core of Milky Way 4.8 million years ago, which gave birth to S5 with a speed higher than the escape velocity of the Milky Way core. Clark et al. In 2018 observed C-Tau, a young 2 million years old star, which is located about 500 light years away. They discovered that extrasolar system contains 4 gas giant planets that are only 2 million years old, an amount of time that is too short for formation of gas giants according to the prevailing theories. This discovery can be explained by gravitational burst of the Milky Way core 2 million years ago, which gave birth to C-Tau system with all the planets generated at the same time. Observations by Event Horizon Telescope collaboration. In May 2022, collaboration presented Event Horizon Telescope 1.3 millimeters measurements of the radius source located at the position of the supermassive black object Sagittarius collected during the 2017 April campaign. A deciphered image of Sagittarius is depicted in figure 5. Take a look at these pictures. This is a figure 4, and this is deciphered the image of Sagittarius A star. The observations were conducted with 8 facilities at 6 locations across the globe. Novel calibration methods are employed to account for Sagittarius flux variability. A few teams of researchers have attempted to image Sagittarius in the radio spectrum using very long baseline interferometry. The current highest resolution, about 30 microarc seconds measurement, made at a wavelength of 1.3 millimeters, indicated an overall angular size for the source of 50 microarc seconds. Take a look at these pictures. At a distance of 26.6 kilolight years, this yields a diameter of 6.3 10 to the power 10 meters. Multi-wavelength monitoring of Sagittarius was performed at 22, 43, 86 gigahertz and at near-infrared and X-ray wavelengths. Several X-ray flares from Sagittarius are detected by Chandra, one at low significance jointly with Swift on April 7, and the other at high significance jointly with New Star on April 11. The collaboration compares Sagittarius broadband flux during this campaign to its historical spectral energy distribution and found that both the quiescent emission and flare emission are consistent with its long-term behavior. Astronomers of the collaboration have made a first comparison of the 2017 Sagittarius data to a state-of-the-art library of ideal time-dependent, general relativistic magnetohydrodynamics simulations models. The models assume that the mass and distance to Sagittarius are known and that the central object is a rotating, uncharged, supermassive black hole. It's a very good beginning. None of the fiducial models survived the full gauntlet of 11 constraints. The astronomers set aside both variability constraints and got 2 fiducial models that passed the remaining 9 constraints in all simulation pipelines. These models in the best bet region are strongly magnetized and have positive spin and low inclination. Based on the obtained results, the Event Horizon Telescope collaboration claimed that Sagittarius is a supermassive black hole. Below, we analyzed the obtained experimental results in frames of room. Analysis of Event Horizon Telescope results. In our opinion, the results obtained by collaboration are model-dependent and not sufficient to support this claim. Astronomers should answer some principal questions. The age of Milky Way is similar to the age of the world. The oldest star in Milky Way, named Methuselah, is nearly as old as the world itself. If Sagittarius is a supermassive black hole, then how it could grow so quickly? What is the origin of the alleged supermassive black hole positive spin? Their models in the best bet region have low inclinations, 30 degrees and 10 degrees, that contradicts the disk shape of Milky Way and bipolar astrophysical jets, which are astronomical phenomena where outflows of matter are emitted at the extended beams along the axis of rotation. The Milky Way galaxy, including Sagittarius, is gravitationally bounded with Virgo supercluster and has a huge orbital angular momentum calculated based on the distance of 65 million light years from Virgo supercluster and orbital speed of about 400 kilometers per second. How did Milky Way galaxy obtain this very large orbital angular momentum? What is the mechanism of gamma rays emission from the galactic center? In frames of WOMB macro-object shell model, which we discussed in presentation 3, the results obtained by the Event Horizon Telescope collaboration can be explained in the following way. The image is dominated by the bright, thick ring with the diameter 6.3 10 to the power 10 meters. The ring has a comparatively dim interior that is made up of dark matter fermions GMF1 and GMF2, which are responsible for the excess of gamma ray emission from the Sagittarius due to their self-annihilation. Dark matter particles are continuously absorbed by the interior of Sagittarius. Ordinary matter is a byproduct of dark matter particles' self-annihilation. It is re-emitted by the interior continuously into the shell around it. Very powerful gamma quants with energy of at least 1 megaelectron volts in the vicinity of atomic nuclei of the shell produce electron-positron pairs with high concentration. The bright, thick area with the diameter 6.3 10 to the power 10 meter consists of ordinary matter and electron-positron plasma with a radius of 2.9 10 to the power 10 meters that is a compact, non-thermal radio object responsible for the strongest radio emission from the center of Milky Way. The area from the radius of 3.17 10 to the power 10 meters to 1.88 10 to the power 12 meters is filled out with dark matter fermions GMF3, which are responsible for X-rays from the center of Milky Way due to their self-annihilation. The 400 times brighter than usual X-ray flare reported by NASA is the result of the detonation process inside of this shell, which does not destroy it. Instead, hyperflare occurred in active region of the shell analogous to solar flares. The enclosed mass of supermassive compact object, 4.154 million solar mass, is the mass of the Milky Way dark matter core made up of GMF1, GMF2 with electron-positron shell and GMF3 shell. Sagittarius has gotten the rotational and air orbital angular momenta as the result of the rotational fission of the dark matter core of the Virgo supercluster. The totality of all obtained experimental results testify in favor of the existence of the supermassive compact object made up of dark matter particles at the Milky Way Centre. Dark matter Fermi Bubbles. In 2010, the discovery of two Fermi bubbles emitting gamma ray and X-rays was announced. Fermi bubbles extend for about 25 kilolight years above and below the center of the galaxy. The outlines of the bubbles are quite sharp, and the bubbles themselves glow in nearly uniform gamma rays over their colossal surfaces. Gamma ray spectrum remains unconstrained up to around 1 tera-electron volts. Years after discovery of Fermi bubbles, their origin and the nature of the gamma ray emission remain unresolved. Su in Finkenbeiner in 2012 identify a gamma-ray cocoon feature in the southern Fermi bubble, a jet lag feature along the cocoon's axis of symmetry, and another directly opposite the galactic center in the north. Both the cocoon and jet-like feature have a hard spectrum from 1 to 100 giga-electron volts. If confirmed, these jets are the first resolved gamma-ray jets ever seen. Ponti et al. In 2019 report prominent X-ray structures on intermediate scales, hundreds of parsecs, above and below the plane, which appear to connect the galactic center region to Fermi bubbles. These structures, which they term the galactic center chimneys, constitute exhaust channels through which energy and mass is injected by a quasi-continuous train of episodic events at the galactic center and transported from the central few parsecs to the base of the Fermi bubbles. Hooper and Slatier in 2013 discussed two emission mechanisms in Fermi bubbles: inverse Compton scattering and annihilating dark matter. In their opinion, the second emission mechanism must be responsible for the bulk of the low energy, low latitude emission. The spectrum and angular distribution of the signal is consistent with that predicted from 10 giga-electron volt dark matter particles annihilating to leptons. This component is similar to the excess giga-electron volt emission previously reported by Hooper and Goodenough in 2011 from the galactic center. It is worth noting that a similar excess of gamma rays was observed in the central region of the Andromeda galaxy too. McDaniel, Geltema, and Profuma in 2018 calculated the expected emission across the electromagnetic spectrum in comparison with available observational data from Andromeda galaxy and found that the best fitting models are with a dark matter mass about 11 giga-electron volts. According to Young, Ruskowski, and Swebel, for understanding the physical origin of Fermi bubbles, three major questions need to be answered. First, what is the emission mechanism? The bubbles can either be hadronic, where the gamma rays are produced by inelastic collisions between cosmic ray protons and the thermal nuclei wide decay of neutral pions, or leptonic, where the gamma rays are generated by inverse Compton scattering of the interstellar radiation filled by cosmic ray electrons. Second, what activity at the galactic center triggered the event? Are the bubbles associated with nuclear star formation or active galactic nuclear activity? Third, where are the cosmic rays accelerated? They could either be accelerated at the galactic center and transported to the surface of the bubble, or accelerated in situ by shocks or turbulence. Note, however, that not all combinations of the above three considerations would make a successful model because of constraints given by the hard spectrum of the observed bubbles. Warm explanation of Fermi bubbles. Warm explains Fermi bubbles the following way. Core of Milky Way galaxy is made up of dark matter particles DMF1, DMF2, and DMF3. The second component, DMF2, explains the excess giga-electron volt emission reported by Hooper from the galactic center. Core rotates with surface speed at equator close to the escape velocity between gravitational bursts and over the escape velocity at the moments of gravitational bursts. Bipolar astrophysical jets of dark matter particles are ejected from the rotating dark matter core of Milky Way into the galactic's halo along the rotation axis of the galaxy. Due to self-annihilation of DMF1 and DMF2, these beams are gamma-ray jets, which were discussed by Su and Finkenbader. The prominent X-ray structures on intermediate scales, hundreds of parsec, above and below the plane, named pointy galactic center chimneys, are the result of the self-annihilation of DMF3. Fermi bubbles are bubbles whose boundary with the intergalactic medium has the basic surface energy density sigma 0. These bubbles are filled with dark matter particles DMF1, DMF2, and DMF3. Fermi bubbles are macro objects with a mass and diameter which are proportional. Mass to Q in power 1.5 and diameter in the power Q in 3/4, respectively. In whom the diameter of Fermi bubbles equals to 28.6 kilolight years, where LDMF3 is the Compton length of particles DMF3. The calculated diameter is in a good agreement with the measured size of the Fermi bubbles, 25 kilolight years by Angulare and Pulliam, and 32.6 kilolight years by Ponti. Weak interaction between dark DMF3 particles provides integrity of Fermi bubbles. With Nikola Tesla's principle at heart, there is no energy in matter other than the received from the environment. We calculate the mass of Fermi bubbles by the same equation that equals about 3.6 10 to the power 41 kilograms. Recall that the mass of Milky Way galaxy is about 1.6, 3.2, 10 to the power 42 kilograms. It means that the Fermi bubbles have mass about 10 times less. Fermi bubbles radiate X-rays due to the self-annihilation of DMF3. Gamma rays up to 1 tera-electron volt are the result of the self-annihilation of DMF1 and DMF2 in dark matter objects whose density is sufficient for the self-annihilation of dark matter particles to occur. On the other hand, dark matter macro objects are much smaller than stars of the world and have a high concentration in Fermi bubbles to provide nearly uniform gamma-ray glow over their colossal surfaces. A total flux of the gamma radiation from Fermi bubbles is the sum of the contributions of all individual dark matter macro objects, which irradiate gamma quants and with different energies and attract new DMF1 and DMF2 from Fermi bubbles. The core of Milky Way supplies Fermi bubbles with new dark matter particles through the galactic wind, explaining the brightness of Fermi bubbles remaining fairly constant during the time of observations. In our opinion, Fermi bubbles are built continuously throughout the lifetime of the Milky Way galaxy. Fermi bubbles, made up of DMF3 particles, resemble a honeycomb filled with DMF1 and DMF2. Conclusion. The totality of all obtained experimental results testify in favor of the existence of supermassive compact objects made up of dark matter particles at the Milky Way Centre and validate the developed world universe model. In our view, Fermi bubbles are dark matter particles clouds containing uniformly distributed dark matter objects in which dark matter particles self-annihilate and radiate gamma rays with energies covering nine orders of magnitude, from kiloelectron volt to tera-electron volt. Dark matter Fermi bubbles constitute principal proof of womb. Acknowledgements. I'm always grateful to academician Alexander Prokhorov and Professor Manenkov, whose influence on my scientific life has been decisive. I am eternally grateful to my scientific father, Paul Dirac, who was a genius and foresaw the future of physics in a new cosmology. I am forever grateful to Nikola Tesla, who was a genius. I am much obliged to Professor Korda for publishing my manuscripts in the Journal of High Energy Physics, Gravitation, and Cosmology. I am grateful to Nick Percival for his useful comments and suggestions, which have led to an overall improvement of the presentation. Special thanks to my son Ilya, who helped me clarify the model and improve its understanding. This is the end of my presentation. Thank you so much for your attention.
Well, thank you once again. Yes, that's fine. Vladimir, and you make a moderator's task very easy because you finish right on time. I don't know how you get it so accurately. You don't finish early, so we have to fill in gaps, or you don't over spend the time allotted. So this is excellent that you've just taken the hour.
Thank you so much. I have some experience, that's why.
You obviously do. You do. Now, a couple of things I want to say before getting on to the questions. I see there are some specific questions that have come in from people like Jim Morrison and Franklin Hu and John Hodge and so on. We could perhaps get to those in a moment. But I'd like to say something first, if I may, in relation to the journal Galilean Electrodynamics. Now, those of you who are aware of this journal or have been subscribing to it will be aware that in the fall of 2021, it ceased production. So it seemed, and I think this was owing to difficulties that the editor was having, in various areas. Cynthia Whitney. However, very recently it has been resurrected, I'm glad to say, and a number of us, including myself, have received these back copies. So I think what they did is they produced the I think it's October, November 2021 and winter 2021 issues. And I think the plan is obviously to fill up the backlog. It'll take some time. We'll be probably getting the maybe early 2022 edition, so that they'll be bringing us up slowly to the present form. But one of the reasons that I've alerted you to this is that in the said issue, I think it's volume 32, there's a paper by Vladimir on his womb model, and he's going into some depth with regard to comparison between experimental observations and what the predictions would be of the model. Well, I think it's a very, very good complement to what we're receiving over these weeks. So if any of you have access to that journal and would like to peruse Vladimir's paper, I think it helps a lot. It actually helped me in clarifying some of the points he's been raising. Now, just maybe a couple of things before we get down to, I'm just keeping an eye to see if there's anything urgent. Yeah, okay. Everything's urgent, I suppose. Right. Now, okay, let's get the comments back. Right. Vladimir has given us some repeat allusions, and he's kindly acknowledged, some of our small contributions in regard to this dark matter business, which, I think he's arguing there is maybe some prejudice against among mainstream and even among dissidents, because of some of the comments that have been made. And he referred to the work of Mitchell originally, and then maybe dealing going forward about 188 years to 1971 with the ostensible identification. I was interested in his saying that despite there being no direct observation of the dark matter particles, he's arguing, I think, that this should not stand in the way to acceptance, because we accept the existence of other particles whose properties maybe are not observed. For example, neutral particles. Now, we can discuss that in a moment. Some people may take issue at some of those points, but it's an interesting point to raise. With regard to the Fermi bubbles, the large structures of gamma rays about the galactic center, and let me see. I was interested actually in his enunciating Tesla's principle of there being no energy and matter other than that received from the environment to calculate the mass of these entities. But perhaps Vladimir, when you come in a second, you might wish to address a very simple point, which I hope you haven't already addressed, and I've missed. I'm just wondering if your enunciation of this with regard to the Milky Way galaxy is singular, or would you foresee that these bubbles exist in all galaxies? That's just one question I have. There are some questions on the dark matter, which we'll get to now in a moment. So maybe I'll restrict my observations at this stage to that. And just if Vladimir wishes to respond in any way, he's been actually quite kind in his sometimes quite direct comments that have been made with regard to dark matter, and maybe understanding some of our criticisms. So maybe just one thing before we get more specifically to the questions and maybe the discussion. Then these Fermi bubbles. Would you foresee that these exist generally in galaxies, or are these singular to our own galaxy?
My understanding of the physics of galaxies, yes, all of them, at least the biggest one, we can find them. And what is important, I didn't tell in my presentation, that the same bubbles, like Fermi bubbles, were observed already in Andromeda galaxy, the biggest one and the closest to us. That's why it is a very good question you ask me right now. And according to physics, if you have rotational dark matter cores, immediately you have these galaxy winds along the axis of rotation. Immediately you have the chance to create these Fermi bubbles. Yes, my understanding that all galaxies have the same feature, perpendicular to the axis of rotation.
Okay.
I mean, along the axis of rotation, but perpendicular to these galaxies. I mean, to the plane of the galaxy.
Okay. Well, thank you very much. So, if we could spend some time just going through some of the questions, a lot of interesting comments here, which I'll not go into in detail. If I'm missing anything, perhaps you could come back. But I have seen a few questions which I think we might deal specifically with. So I just beg your patience because I have to go to the list here in StreamYard. Right. So very good. We had many comments first, and just questions between yourselves. Yeah, okay. And we'll come to the green room comments in a moment. Okay. So this is Franklin's point. What is the relationship between the electron and the womb dark matter particle? Is an electron fundamental or made out of DM womb particles?
I told many times that in the medium we have fundamental particles, proton and electron. We have intergalactic plasma.
So it's the same. The electrons will be fundamental.
Electron and proton the same. And that's why I have to introduce Dirac's to provide existence of electrons. You see what I mean? Because there was a Dirac quantization principle. If you want to have stable the same charge of all particles, you must have monopoles, Dirac's monopoles. Instead of Dirac monopoles, I introduced Dirac's dipoles named Diracs. That's why it was in purpose I introduced this particle, Dirac, to produce electrons with a stable electrical charge.
Okay, so that goes back to earlier discussions about how different the dark matter constitution might be. I wasn't sure if we dealt with this, but question has raised it again. I think he said the dark matter isn't charged. I think that dark matter doesn't have any charge. Is his interpretation correct, or did you say that?
It is correct. There is no charge.
Okay, that's fine. Thank you. It's useful to get these concepts into our minds. Now we're getting to this pinch effect. Is something else? There's some other points here which are interesting. And interestingly enough, just again going over the tangent, I was talking about the good weather, but we're having, as I'm sure many of you know, a maximum activity, solar activity at the moment. And in fact, last night there were some sightings of the Northern Lights in Ireland, which is really a very singular activity. So I've seen them in Norway up past the Arctic Circle actually many years ago, but I've never seen them here. I think also tonight there'll be some possibilities of looking at them. Now, here's where Jim's point, which I wanted to raise because I looked at it earlier. So Jim Morris says, I suggested there's maybe this isn't the one I was looking at. I suggested there's an ether with a minute and variable mass density proportional to the gravity. Yeah, no, this is the one I wanted. I suggest that there is an ether with a minute and variable mass density proportional to the gravitational potential, and that is the nature of dark matter. Have you any comment on that? Good, bad, or indifferent, Vladimir?
No, there is no ether in my model. It's totally different entity. Medium different from ether, no doubts about it. Because ether is something unknown. I saturated my medium with the real particles, with the real numbers, pictures, and so on and so on. It's totally different story.
Okay, so I wanted to clarify that. Now let me just say. Okay. Now, something Franklin can be a bit direct, but that's fine. What is the actual physical difference between DMF1 to 4? Could any experiment be created to detect the difference between the different types, 1, 2, 3, 4? Or is this a difference in your imagination?
It's not my imagination, sorry.
Right.
It is experimental results. I tried in my second presentation to show the existence of gamma radiations with the right energy out. Giga-electron volt, tera-electron volt, and all this stuff. That's why it is not. The second point, if there is no direct observation, it should be indirect observations. And in 1977, two Nobel Prize laureates in physics, guys, they first introduced annihilation of dark matter particles with radiations, gamma and astronomical radiations, that's galaxy radiation. That's why, it's not my idea to study dark matter particles by gamma radiations, the proper gamma radiation. And it is exactly my proposal. Use the standard masses of gamma of dark matter particles and take a look at the signs of these dark matter particles in the observed very high energy gamma rays. On the contrary, you see, it's much easier for us to detect and to observe dark matter particles by gamma radiation. What we are talking about neutrons, supposedly. Neutron, we know nothing about it. We have to take one charged particle, another charged particle, subtract one energy from another one, then subtract some additional energy, and all then we can find mass of neutrons. Whereas in direct, there is no even indirect, observations. By the way, for dark matter particles, it is a direct, indirect observations. I mean by gamma quants. Watch in the universe, in the world, your gamma quants and find the signs, the numbers according to the proposed dark matter particles rest energies.
But it's only the different types of particles composing dark matter which differ. Is that correct? You don't conceive of there being different types of dark matter, as question has asked here, do you?
No, there are different types, DMF1, DMF2, and the difference is only in the rest energy.
Right.
One is 1.3 tera electron volt, another one is 9.6 giga electron volts. That's it. And there is only these numbers, rest energies, I introduced about dark matter particles. I don't know anything about structure, about all these parameters from so-named quantum physics. I hope that maybe quantum physicists, they will take care about these particles. Because for classical physics, observations we have, it's gamma quants only, not gamma quants, gamma radiations. We need only these, dark matter particles, rest energies. That's it. All the rest parameters, it's a responsibility of quantum physics.
Okay. There are other things about ether which are interesting, but they're perhaps not totally germane to the questions here. You've given us your position on that. Now, I saw this by John Hodge coming in, and I'm not sure if it's quite clear or if you can address it. He said you presumably are presenting evidence that matter objects are emitted from the center outwards, and John then says contrary to Big Bang, which suggests inflow of matter. Does that make sense to you?
I misunderstood. What about Big Bang? There is no Big Bang at all. Forget it. It's obsolete.
Yeah, of course, because you look at sort of an origin of the universe, and you look at a relatively short period, where there's only dark matter, and then you have the evolution into non-dark matter, and it's like instead of being, it's 13.77 thousand millions, and then you have 0.41 or something before that. So I don't know if John wants to clarify that. We might be able to come back to it, but
okay, I'm ready to clarify. I will get the question because I'm so sorry. Maybe I misunderstood it.
No, I'm not sure.
Dark matter particles, they are not going to our world only for 500 million years before luminous world. Continuously, they're coming to us continuously. Even
yes.
now, we have all this. We have a dark matter reactor inside of our Earth. I told many times. We have these dark matter reactors in all macro objects. I'm sorry. That's why it's not right to think about dark matter particles only in that epoch. No, it's always continuously.
So
And
Franklin,
let me clarify about ether. Ether, I'm tired about ether. Ether, it's unknown perfect liquid or something like this. But what kind of liquid we can talk about if we have a concentration of protons, 1 proton for 4 cubic meters? What kind of liquid if the distance between them meters? That's why it is a medium. It's like a gas. It's not like a liquid. That's why all these speculations about the liquid, perfect liquid, and all this stuff, there is no base. There is no reason for this because of the concentration. It's a gas
very
of
low.
different particles.
Franklin is asking, how do you come up with the structure? Sorry, I've just forgotten. What's SBH using DMF? Why not center made up of DMF4 or DMF3? What constrains this? He's got a few things in that. I'm not quite sure. Do you follow that? What he's asking, Vladimir?
Yes, I can understand it, because first of all, each DMF I introduced each depends on a macro object. If it's a star, it's one. If it's a galaxy, another one, and so on and so on. But it doesn't mean that they're only these particles, because envelope means the edge of each cell. But all the inside, there are the same particles. They belong to macro objects too. It's only part of it. The main part, supposedly for galaxy, is DMF3 because because of weak interaction, it holds the whole structure like a bubble. But it does mean that there is no DMF4 and all other DRX and all the bosons and so on and so on. All of them inside of it. But the responsibility of DMF3 to hold this disk bubble like a bubble with a boundary between galaxy and intergalactic medium. That's why all of them inside. But who is the main player? That's it. Russian doll, it does mean that there is only one type of particle. It means all together, but lighter particle, bigger size, bigger diameter, bigger mass. That's it.
Okay. Well, I think 4 different types of DMF. Okay. Well, I think since time is passing on, we might pass, because there's some further questions which are just going again into the same area.
It's good. I like questions.
Yeah, of course. So Franklin has come back again. He says, principle proof, proof of principle, I don't know, would be doing something like creating a beam of DMF particles showing they can be detected and turning it off and on to demonstrate the existence. I'm not quite sure if that was the...
Let me tell you one more time. I don't understand this question, but we have excess of 10 giga-electron volts radiation from the center of our Milky Way. Let me ask you the question. Who is responsible for it? That's it. That's why I saturated center with DMF2 with 9.6 giga-electron volts rest energy. Simple like this, Anytime you want to have confirmation of some dark matter particles, look at gamma spectrum. By the way, our world is filled out with so much gamma spectrum. There are some special catalogs, and at least half of our sources in the universe even not detected, not observed. They don't know what is the reason for this. That's why I will try to help astronomers to see their gamma spectrum and try to to find the sources of it, what kind of dark matter particles you have. And what is important, it's not my idea even. As I told you, in 1977, it was a pioneer particle by two Nobel laureates in physics. Maybe they were smart guys, they proposed this idea. I'm following this idea.
Okay. So this is what he said. How does the gamma ray spread constitute? Now, I'm not sure if he means a principal proof, maybe, or a proof of principle. But anyway, it doesn't establish the four different kinds of DMF or in any way establish the independent existence of each of the DMF 1 to 4. How does the gamma ray?
As I told you, there is no, I'm so sorry, there is no macro objects with one type of DMF, 1, 2, 3, and 4. All of them, you have your mixture. Everything depends who is the main player. If you are going to supercluster, you have the biggest shell made of DMF4. The same story with galaxy, DMF3. For the same story for extrasolar systems and so on and so on. That's it. Always you have a mixture. There is nothing unique, DMF1 or DMF2. No, all of them inside of each macro object. Everything depends. What is the concentration? What is the part of it? Which one is the main player? In galaxies, the main player is DMF3.
Okay. Right. Well, I think we should really let some people come in and talk on the green room because we're running out of time and it might be more productive to cover some of the things. Now, the first thing is I think, wait a minute now, comments seem to disappear. Not much good. Yeah, here we are. James Keane had a number of points about why are radiation jets along spin axis? Do radiation jets exhibit or have attribute of linear momentum? If dark matter emits EM radiation, then it is not dark, right? Well, why not let Jim ask those questions directly, if I may impose upon him?
Okay.
So, Jim, may I ask you to raise those directly rather than have me as an incoherent intermediary?
Well, thank you, Ian, and I'd like to congratulate and give great credit to Vladimir for his scholarly work in reviewing so many papers in cosmology and his data-based analysis of that information. It's very impressive.
Thank you very much.
Yes, sir. I'm not an astronomer for sure, so I seek better understanding of some of your terminology. For example, what exactly is self-annihilation? How could you define that for a non-astronomer or for a particle physicist? What you mean by that?
I'm not astronomer too. Thank you so much. I'm not. What does it mean, self-annihilating? It means that each particle, if it is an antiparticle at the same time. Majorana, about 100 years ago, introduced such fermions in quantum physics. Majorana fermions, particle and antiparticle, the same particle. They have this feature. They can, annihilate with each other, and they don't need antiparticle. They are antiparticle by themselves.
And where does the energy go? Is energy conserved in this self-annihilation process?
Yes, they are going to gamma quants because when you have nuclear reaction, annihilation is a nuclear reaction, you have gamma quants. This is the main output of this annihilation. And this is the main instrument to watch what kind of self-annihilated dark matter particles you observe.
So would your work be consistent then with energy in the form of angular momentum being transformed, if you will, to linear momentum in the radiation jets that you speak of.
Yes, linear momentum is along to axis of rotation. Yes, but it is already particles. It's gamma quants. It's, some stream of the particles going to Fermi bubbles. Yes.
Okay. Why? Thank you. Why are the radiation jets along the spin axis of your celestial objects here?
The mechanism of this injection, I refer to the scientist. Unfortunately, I cannot name him right now. And it is theoretical work for the rotating bodies and rotation. I don't know how to tell it. That because of rotation, you have a stream of particles along the axis of rotation. These jets of even solar system, in our sun, in some other system, they experimentally observed in all macro objects around us. It's not the idea I generated. I use the ideas. By the way, what I'm doing in my model, let me tell you why I have to learn so many so many papers, so many articles. I'm trying to find the right guys who propose some idea before me. I'm trying to use the ideas existing. What is my main objective is to be a conductor of all these ideas, that they will play the same use. Sorry for this reference.
Well, thank you. I'm interested in this because your work seems to confirm, if I may, my own work in binary mechanics, where the equations result in this sort of radiation jets along the spin axis as a possibility, and the interchange between linear and angular momentum. Last question, just about terminology, I guess, sir. If dark matter emits EM radiation, then terminologically speaking, it's not really dark. Would what do you say about that? It's just what we call things. You're calling it
It's a
dark,
bad
but
word.
it's emitting radiation. Well, that's not dark, is it?
As a result of the self-annihilation of them, exactly we can already see gamma radiations. In this, in this story about dark star 240 years ago, they named dark. It's not me. And dark means that you have no visible radiation. Dark, it does mean that there is no radiation at all. It means that you cannot see with your eyes. That's why
Okay,
there
thank
is
you.
no visible spectrum. There is no visible wavelengths. That's why you cannot see them. But you're absolutely right. As a result of the annihilation, we have gamma quants, and not only gamma quants with electron volts, macro electron volts. No, we even 21 centimeter radiation, what we have right now, it's radio waves. It's the result of self-annihilation of dark matter particles, boson, xions, with rest energy 5.3 microelectron volts. That's why everything depends on terminology. You're absolutely right.
Yes, yes.
And dark, in usual manner, is only visible, non-visible. That's it. You're absolutely
So,
right.
so it's a question of
It's a good
definition of
question.
terminology. I mean, it might be noted that light is invisible. It's only when it impinges upon something.
Yes,
Like,
most of the time we're going infrared light, but there is no light infrared. Infrared
well,
means we cannot see
but
it. It's a
visible light
terminology
itself
issue.
is the waves or the particles of light are invisible to us. It's only when they interact with other material. Anyway, is there anything else, Jim?
Yes,
You'd like
one
to
last point, and this may be the most important one. The figures you gave for the what we might call a microscopic measure of time, 5.9 to the 10 minus 23 seconds, and for length 1.77 to the 10 minus 14 meters that you gave at the beginning of the talk are not far from the values discovered in binary mechanics. So I find your work very intriguing and will strive to understand it more. Again, congratulations, sir, on your work. Thank you, Ian, for the time.
And
Thank
you
Thank
very
you
much,
so
Jim.
much for a good evaluation and good questions. Thank you
And
so
if any
much,
of my small
especially
version
with
of
this
any use,
terminology, dark.
I would
Oh
encourage
my
you
goodness, it's
to,
a very good
gentlemen,
question.
to keep in touch, because it's quite interesting if your ideas, which are sort of not totally familiar to many of us, not totally foreign either, if they're coming to the same values. So that's quite interesting. So thank you very much.
Yes,
Thank
that
you very
is
much.
something sensational in
Yeah.
the first part of Vladimir's talk today. I found that the values for a microscopic, if you will, unit of time and of length is very close to those values determined in binary mechanics equations. Thank you.
Okay. Well,
Thank you
thank
so
you very
much.
much.
Thank
Thank
you
you
very much.
again, Jim. Now, Dennis P. Allen has been putting his hand up. I'm sorry, couldn't get to earlier, but you're up now, and the floor is yours, Danny.
Thanks, Ian. I'm impressed too with all his hard work, but I find I can't take his most of it what he says seriously. For example, it's now known by Bill Lucas, who's
We're getting some breakup of your mic, Denny. Are you also?
well. Let me turn off my fan. Maybe that'll help.
Yeah.
How is that? Is that a little better?
I think that is better. Yes.
Yeah, that white noise. Well, as I was saying, I'm impressed by Vladimir's hard work and everything, but I can't take most of what he says seriously. For example, Bill Lucas published in his book, The Universal Force, and new gravitational law, and he showed in further publications, not in this book, but in further publications in Dave Bergman's journal, Foundations of Science, that there's no need for dark matter because if you look at the fact that at his revised gravitational force, what caused the adoption of dark matter is that Einstein's general relativity was to the first order is the same as Newton's law of gravitation by postulate. Showed that the galaxies weren't behaving according to Einstein's general relativity or Newton because they weren't behaving, from the viewpoint of Newton's law of gravitation. So they cooked up dark matter to solve this problem. Instead of looking into the gravitational law and noticing that Bill, in his book, The Universal Force, has derived a new theory of gravitation, which explains the phenomenon, the galactic phenomena that was previously explained by attempted to be explained by dark matter, but there's troubles with dark matter. It's sort of ad hoc. And as I say, if you use the correct gravitational law, you don't need it. This law was first derived by curve fitting from an Israeli scientist. And then Bill, by his theories, derived this curve fitting law, which then showed no need for dark matter. I might add that this is typical of the way physics goes nowadays. If somebody doesn't obey your laws, then there must be something like dark matter floating around somewhere to explain it. Your laws can't be wrong. You know, those laws are gospel. But and that's the reason why, for example, gravitational waves are claimed to have been detected. You know, they're cooking gravitational waves out of Einstein's field equations in its general theory. Actually, it was due to Herman Weyl in his book Space, Time, and Matter. But it's so the LIGO or LIGO, I don't know how you pronounce it, LIGO people claim they've detected gravitational waves, but there's a new gravitational wave detection center called KAGRA, KAGRA, which detects no gravitational waves, which seems to be because there aren't any. What the LIGO people are detecting, according to, for example, retired astronomer Richard David Scott on ResearchGate, what they're detecting is things like the position of the sun and the moon in the Earth's sky, which control the tides. In other words, their equipment is so sensitive that it's sensitive to tidal forces, not just tides on the ocean, but there's tidal forces throughout the entire Earth. And these are, so the position of the sun and the moon in the Earth's sky is heavily correlated with the detection of gravitational waves, but they're supposed to be from another galaxy way far away, by the merging of two neutron stars. Well, what are neutron stars? Well, it's something left over from the standard model. If there's so much gravitation that collapses the protons and the electrons, they form neutrons, according to this theory. But, you know, Ron Hatch, for example, in his paper on New Theory of Gravity, published in 2007 Physics Essays, points out that this can't really be. So I would say that I don't think cosmology can really be done correctly nowadays, you know, outside of the solar system where you can get some real data, because the basic laws of particle physics and gravitation and whatnot have not as yet been made clear, correct, in fact.
Right. Well, there are a number of interesting points there, and I don't know how you might respond. I mean, I might just, while you're thinking just for a second there, be bold enough to come in and say, this might be leading to some of the sort of prejudice that you envisioned, Vladimir, because many of us dissidents would share those views that Dennis has talked about, you know, about the ad hoc nature of the invention of dark matter. And I talked briefly on our post conference chat just briefly 2 weeks ago about my own idea about looking at distant parts of the universe, which it's not a simultaneous snapshot. It's a composite of things that have taken place maybe millions of years apart from each other. You know that point. So I suppose in a way, would you distinguish your own ideas of dark matter from what gave rise to it being introduced into ordinary scientific lore?
Sorry, we interrupted.
Do you understand what I'm saying? I'm sorry I did interrupt, but like Denny has raised quite a number of points which we could easily spend half an hour on. We don't have the time. We're going to have to end the conference soon, and I might be able to give one more person a chance coming in. But like Denny has criticized very much the incidence of the introduction of the concept of dark matter among mainstream science. And he's given some reasons which we could argue about, yes or no. But is your conception different from that, Vladimir? you know,
I'm very sorry. I
basically
missed your
he's
question
interpreting.
because there was some break in this, transmission. Please repeat your
So you
question.
didn't get it all.
I'm sorry?
Okay. You didn't get all of what Denny said. There was a break.
Danny said yes, but when you started to talk, it was some break. And we didn't see not you, not me, not Jenny.
Okay.
Danny.
What I said is neither here nor there. I probably was making things more complicated, but it's just that I wanted you to concentrate perhaps on maybe one point, if I may, of Denny's, that the introduction of dark matter, so he contends, was really a curve-fitting exercise, and many of us would agree with that. So do you conceive that your own ideas of dark matter differ fundamentally from what gave cause to mainstream science introducing it maybe years ago?
Mainstream science didn't use dark matter for all the physical phenomena I'm speaking about. They didn't use it. There was only one trial to explain rotational curves of galaxies. It's wrong. We don't need it in here. And there was some attempts to explain gamma radiations, by the way, by Hooper, by some other guys, of this excess of 10 gigaelectron volts radiation from center of our galaxy by annihilation. And I refer to these papers. There were some papers even earlier. I spoke on them at my second presentation when gamma quant from different objects were explained by possibility that it might be some dark matter particles annihilation. But what is important, as I told you, the very first really well-known pioneer articles were published in 1977 by two very smart guys. They told that these cosmic rays, gamma electron walls, and all these energies can come from the center of galaxies with annihilation of heavy leptons. And leptons, it was a cold dark matter. I'm ready to return to my presentation and to show this reference. It's me. As I told you, I'm trying to use ideas that belong to some very smart guys, in much earlier than myself. That's why it is not that it's mine. On the contrary, as I told you, even in the first particle, it was annihilation of such cold dark matter particles. It's written directly what they proposed.
So gentlemen, just maybe to add to this, I have a voluntary statement from Nick here that he's able to add to this, particularly the point that was raised by Denny. So could I bring him in now? There's nothing more you want to say at the moment, Denny, is there?
No, that's it.
Well, thank you very much. Thank you very much, Denny. Thank you for that. Now, let me see. Get my So Nick, good day to you. You're up now. So what did you want to add or to what Denny?
Yes, Dennis gave a very accurate critique of mainstream academic physics idea of dark matter, which I also dismiss. But that's totally different than what Vladimir is talking about. And hence we have this terminology. So a lot of people are dismissing Vladimir when he talks about dark matter based on ideas that are totally irrelevant to his thesis and why he has come up with dark matter particles. So hopefully this will help people to not prejudge and dismiss what Vladimir is saying when he uses the term dark matter. When I first read Vladimir, I came up with pretty much the same cynicism about theory using dark matter, but having gone through this several times with Vladimir, I now see that there's a qualitative difference between the physics academia's original concept of dark matter and the concept that Vladimir has, that has come about from a lot of empirical data that is qualitatively different than what Dennis was referring to. What Dennis was referring to really were dark fudge factors used by physics academia to fill the gap between the empirical data and their flawed laws, whereas Vladimir is just talking about empirical data, totally different empirical data, and coming up with very compatible explanations for those that physics academia and cosmology has not yet come up with, or a few people like Vladimir are coming up along the same lines as Vladimir, but they haven't been totally accepted. As Vladimir said, we need a new paradigm in cosmology.
That's useful, Nick. Thank you for that, because I rather suspected much of that, but I have it clearly stated. So maybe the play is going forward now for the next number of sessions. We need to consider that what Vladimir is saying, even though some of the terms are maybe similar to what mainstream has used, many of us might think inappropriately we should suspend our judgment and just look at what Vladimir is saying and the empirical evidence that he has to substantiate that. So is that okay, Nick? I'll
yes.
Thank you for that. Thank you. Indeed.
Thank you so much for your comment.
Yeah. So, right. Well, and there are other comments, and there are other people in the green room that unfortunately we don't have time to bring in today. There's Franklin and Cornelis, for example. But don't worry, gentlemen, you'll have an opportunity. We have 4 more sessions to go through before the summer, and we're indebted to Vladimir for all the work he's putting into it. And actually, that has been acknowledged in some of the comments. So what I'll do, and they're still coming in, but what I'll do, with all of your permission, is I'll give the floor again to Vladimir. He's probably said a lot, but in case he wants to say anything more just before I officially close the meeting. So Vladimir, I'll give you the floor again for a couple of moments if you want to say anything more. If all.
Let me first of all to say you thank you so much for all your questions, for clarifications of some notions, of some, laws, of some experimental results. It was very important for me to find all these questions. I don't understand what does it mean standard cosmology and standard dark matter particles, dark matter. I will tell you why. Because in our Big Bang model, that big ordinary matter, and then suddenly we have a cold dark matter, hot dark matter. It cannot even tell, they didn't tell even where it came from. From the beginning of Big Bang, it was some electron, proton, some charges, and so on. That's it. Neutrons, and that's it. And suddenly, to explain all the experimental results, they introduced dark matter and dark energy. And nobody never told where it came from. This is my very first moment. That's why to compare my dark matter particles with dark matter non-existent in a standard big model, it's not fair. There is none. And what is important? The important issue is that dark matter, if you may name only like a dark matter, you don't see it. It's dark galaxies, dark stars, and that's it. There is no physical characteristics, parameters of it. My main objective was to saturate the notion dark matter with different particles and explain many, the last my 8 session, I will tell you how many unexplainable phenomena I can explain in frames of new paradigm. It's a new paradigm. It's not the same or improved Big Bang model. No, Big Bang model is obsolete for me. We should build a new model, a new dark matter model, where the main players are dark matter particles, dark matter, because 92.8% of our existing matter in the world, it's a dark matter. How we can build the model based on 2.4% of your matter and miss our dark matter 92.8%? Why we never talked about angular momentum? It's a pollution in a Big Bang model, that's it. And only in my model, there is a principal explanation why we have angular momentum for all galaxies, for all macro objects in the world. That's why, please, try to go to a new approach, to a new paradigm of the existent world. Don't, I'm talking to all the members, don't try to compare what was before and what is now. There is no correlation between the physics before and now. What is important, let me tell you, I believe 100% to astronomers. So great, observations we have right now. And they're trying to explain these observations in frames of non-existent Big Bang model. There is no existence. And I'm easily explaining all these unexplainable phenomena in frames of my standard cosmology with a very simple equations, with the very simple ideas. That's why I invite you today and next time to be more flexible in your view of the world, of the model, and try to understand that there are some principal ideas I introduced in my model that don't exist in existent Big Bang model. They cannot explain so many phenomena, so many issues, even our center of our galaxy, this rotational black hole, it doesn't work at all. There is no rotation, there is no black hole, there is nothing. And nevertheless, it's the main right now explanation of the center of our galaxy. Sorry for my emotions. I know that it is difficult for you to accept these new ideas. That's why I used the proposals, the suggestion of Nick to read my papers. Why? Because it's very difficult to understand by ears. It's better to read something. And even reading of my test, it helps maybe a little bit, but not much to overcome your prejudice against dark matter particles. You know why? Because in the Big Bang model, in existent cosmology, there is no really dark matter. There is no dark matter energy, dark matter particles. There is only something, mathematical manipulations, as Nick told the last time. Thank you so much for your attention, for your questions. It will help me to be better with my next presentations. And I will see you in 2 weeks. Thank you so much.
Well, thank you for those concluding remarks very much, Vladimir. And well, it devolves upon me once again, to thank Vladimir for the very considerable amount of trouble he's gone to. He's obviously been working on this for many, many years, and he's expended a lot of energy. But nevertheless, in order to put it together into a typed script and to go through it in detail, and then to deal with all these fundamental questions, many of which he's probably had already, requires a lot of work and a lot of patience. And, you know, I for one, certainly forgive him for his summary there. In fact, I thank him very much for that, for his frank speaking about our issues. And we did actually say at the beginning that we would ask you to bear with us while we had the opportunity of hearing these 4 parts of this very extensive subject, a very extensive model that Vladimir has been engaged in for many, many years, because there are certain things which might appear to be a bit irregular or maybe too near the mainstream because of terminology. He's actually clarified now quite clearly that many of the terms that we're using in ordinary language, they might concur with those being used by main scientific ideas that are actually not consonant with his, and we should really bear that in mind. And we should certainly bear it in mind for the next number of lectures we'll have over the next number of weeks, where he'll be dealing with this. He dealt, of course, with the subject dear to our own hearts, which would be our own home, our own Milky Way galaxy. But that's just really a paradigm for what is existing in other parts of the universe, other distant galaxies, and so on. So we'll do that. Please feel free to raise your questions again, and even your criticisms, and we'll raise these points again in light of other aspects of the WUM model that Vladimir has developed, and where there are similarities with other work such as Jim's work, or whether there appear to be too close associations with mainstream work, which many of us have rejected. Well, let's listen to him, and let's bring in all the parts together. And then when we have, I think we used the German word Gestalt earlier on, in that the whole will be more than the sum of the parts. So when we get that model in, I'm looking forward to more detailed discussions later on during the summer. So thank you all very much for your engagement. It's been very exciting. I love these discussions, emotion, or it's all in good form, and your questions are very welcome. I'm sorry if we didn't have time to deal with them all, but maybe that's part of the positivity as well, that we're not short of contributions. So I look forward to welcoming Vladimir again in 2 weeks' time. That's the plan. So keep an eye on the notices and exactly what will be promulgated at that time. And I look forward to your contributions, and all of you in the green room coming back again. And the final word must rest with Vladimir himself for all the sterling work that he's done, and given us the benefit of it as well. So once again, I'm going to end the stream now, just a few minutes over the scheduled time. Good day to you all.